Greetings, everyone, and welcome to the BeConnected conference. I'm Neha Dubey, your host for this session. I'm delighted to introduce Mr. Ratnikaran Rajgopal, who is joining us once again at this year's BeConnected conference. Ratnikaran made a significant contribution at the BeConnected 2022, and this time he will be sharing insight on the topic of smart data integration. In addition to being a prominent figure in the tech industry, Ratnikaran is renowned for his deep expertise and profound insights. Over the course of his career, he has demonstrated an exceptional ability to navigate the interface of data migration, conversion, and integration projects, earning the trust of Fortune 500 company. Ratnikaran illustrates his career is a testament to his wealth of experience in critical areas, including application data integration, migration, enterprise data management, data reconciliation, and bulk data loading. His contributions have made a lasting impact on the field, and his insights have paved the way for innovation and excellence in the data management. We consider ourselves privileged to have Mr. Ratnikaran as a valuable participant in this conference, and his wealth of knowledge promises to be a source of inspiration and learning for us, for all of us. Please join me in extending a warm welcome to Ratnikaran as he shared his profound expertise with us today. Thank you, Ratnikaran, for being here today with us. It's a pleasure to welcome you back to this virtual stage. So before we delve into the presentation, I'd like to remind the audience to send in your questions by typing them in the Q&A window. We'll make time at the end of the webinar to answer them. Additionally, we are going to have an assessment test where you have the opportunity to earn a certificate issued by Chainsys related to the smart data integration software on a product data Zap. More details I'll share at the end of the webinar. So the stage is now yours, Mr. Ratnikaran. Over to you.
Thank you, Neha, for your intro. Hello, everyone. Thanks for joining us today. So in this session, we're going to see the overview of smart data integration features that Chainsys offers for the enterprises. So here's the agenda. So we'll see a quick overview of Data Zap, which is a smart integration platform as a service that Chainsys offers. And we'll see how it's built on low-code approach. Then we see the integration migration components of it. Then we'll go on the actual integration topics like extraction, transformation, validation, and data loading. And then we'll see what are the endpoint connectors that we support. Then data mapping and data integration and data migration in detail. Let's get into the session. So Chainsys offers Data Zap, which is a fully managed integration platform as a service that allows users to integrate and migrate from any source like cloud platform or on-premise systems to any target system of your choice, which gives a flexibility to leverage your live data in leading analytics or any business intelligence system, marketing, accounting solutions. It supports cloud to cloud, cloud to on-premise, on-premise to cloud, on-premise to on-premise, data integration migration. It supports near real-time integration and meets all your high-volume ETL needs. Why Data Zap? It's a one single platform which offers data integration, migration, reconciliation, setup migration, big data ingestion, and enterprise data management. A whole lot of things. And it has 10,000 plus pre-built data adapters to ensure coverage of more than 200 applications. It's completely configurable, agile, and built on low-code, no-code approach. You can develop integration flows that connect to applications residing in cloud or on-premise systems. Which has an inbuilt end-to-end quality engine to profile, cleanse your data, transform, validate, and enrich your data. So this slide shows you how the platform provides the low-code, no-code approach in 4 layers. We start with the foundation. So the foundation, we have the components like workflow, versioning engine, API gateways, collaboration, security. So everything is built on a low-code approach. So any user can configure it without much technical knowledge. It's completely drag and drop configurable items. And with a simple, just a few clicks, you'll be able to publish any object as a REST or SOAP API without any additional coding. And next layer comes in the application engine, where you do the actual data movement logics like data extraction, data transformation, data loading, and data reconciliation. So everything is built on a no code, low code approach. You just need to provide the APIs that you want to call. That's it. The rest will be taken care by the system. And the third layer is we provide 10,000 plus smart data adapters for over 200 plus applications. So which gives all the customers to do a quick start. So as soon as they get the license, they'll be able to start their migration or integration activities immediately. And then we take the low code approach to the next level by providing the data mapping filter pre-built adapters as a ready-made solution. So by which you'll be able to quickly move your data between different applications. And this slide will show you the data integration migration components, which is part of Redis app. On the left, you can see all your endpoints, which are grouped into different categories like relational databases, enterprise applications, cloud applications, big data databases, NoSQL databases, enterprise storage systems, and message brokers. To connect to these endpoints, there are dedicated connectors we build like JDBC for connecting relational databases, SAP JC for connecting SAP systems, and REST SOAP APIs are used for connecting to most of the cloud applications. Like that, it goes on. And then by using these connectors, we extract the data and load the data. In the extraction, there are many features we'll see in the next slide in detail. So once we extract the data, then we have the loading engine, which loads data into the target system. So the extraction engine extracts data from the sources and load adapter loads data into the target system. To connect these two, we have a data flow adapter, which provides the data mapping. And in addition to that, all the active transformations are kept at the data flow level. Then we offer a unique feature called migration flow for managing and orchestrating complex data migrations, and process flow for orchestrating complex data integrations. And we offer data exchange and API gateway for publishing any of your objects as a REST or SOAP API to consume it from any third-party systems for near real-time integration. Then we have a scheduler for batch mode integrations, and it comes with a built-in versioning engine. You can make use of any of your versioning repositories of your choice, like SVN, Git, GitHub, GitLab. So you don't need to go out of the system for doing versioning your objects like check-in and check-out. So you can just create a connection to your versioning repository of your choice, and rest all taken care of within the system. So to move data, it starts with a connection and then the data extraction. So in the data extraction, we offer incremental and full reference features, which is the full reference is mostly used for data migration scenarios where we move data from one system to another system as a one-time effort. Whereas the incremental data extraction is used for integrations. Like incremental is nothing but it extracts only the records which got modified or created after your last extraction. So it extracts only the delta changes. And then we have the filters. In filters, there are two options like static filters and dynamic filters. So filters are generally used to filter out unwanted records while extracting from the source system, which you don't want to move into your target system. So if you apply a static filter, what does it mean is whenever you execute the extraction, the same filter will get applied and same parameters are passed to the source extraction and the same data being extracted. Whereas in the runtime filters, the parameters are passed at the runtime by the users who executes the extraction process. So wherein they can provide any value of a choice at the runtime where it would be useful. For example, let's take a scenario where you want to migrate your data from one source system to another system, okay, where in your source system you have different regions data. The requirement is you want to move the data region by region. In those cases, you can define this region as a runtime filters, and you can, whenever you run it, you provide the region name, whichever you want to move at this moment. So by which you'll be able to dynamically control the filters. And you can define whether it's mandatory or optional also. If it is optional, you don't need to provide value for those filters. In those cases, if you don't provide, those filters will not get applied in your source query. If it is mandatory, it will enforce the users to provide a value for the parameter. And you can define default value also for the filters. If you want, you can change it at the runtime. And next, it offers a preprocessor, which is basically used to run a SQL or a stored procedure just before your extracting your data from the source system. The example would be like you may have a complex logic to prepare the data. In those cases, you might have written a SQL procedure which does all the complex logics and build some data and put it in a table. And after that, if you want to extract that data from that table, then this feature will be really helpful. The next comes the unique feature that our extraction adapter provides is predecessor successor. It's a combination of two data extracts. One acts as a parent and another acts as a child. Say, for example, you have a source system which is a kind of a project management system. Okay, so you have stored all your project's data in that system. That system provides an API. Okay, so there are two APIs. The first API will provide only the project IDs, all the project IDs, whatever you have stored in your system. And the next one provides a API for which you need to pass the API ID, project ID as the input, so that you'll be able to get all the details of the project. So the first one returns all the project IDs created in the system, and the second one returns the details of the projects by passing the respective project ID. So the requirement is, so we need to extract all the projects details from the source system. In those cases, say for example, let's assume you have thousands of projects created in your system. In those cases, you need to call the API 1,000 times repeatedly, manually, somehow. Okay, it's a kind of a tedious process. To simplify the process, we introduce a predecessor successor concept. Basically, what it does is, in the first data extraction, which is a parent data extraction, in which you just call the first API, which is going to return all the project IDs from your system, and then under that you attach the next child data object, which is going to receive the project ID from its parent and pass it to the source system and get the data. So this is how the predecessor successor concept is implemented. This is passive transformation. So in the transformation, we do offer two types, active and passive. Passive transformation doesn't change the number of rows passed as input to the transformation, whereas active transformation changes the number of rows what it receives. Let's see the lookup transformation. Lookup transformation is nothing but it looks up data in a lookup source based on the value whatever you receive from your input data, and returns the related value from that lookup source. The lookup source can be a database, a table query, or a flat file, or a REST API, or SOAP APIs, response payload. You can use any of this as your lookup source. And the lookup source should have the corresponding mapping in your for your data. The next comes the sequence generator. The sequence generator is used to generate running sequence numbers. Generally, it's used to create any IDs. For example, when you load data into the target system, for the primary key, If you have to pass the value, then you can make use of this sequence generator transformation. In addition to that, the running sequence codes like purchase order numbers, sales order numbers can also be generated using the sequence generator and expression transformation. You'll be able to achieve it. Next comes the expression transformations. It receives one or more values as input and generates a new value. Basically, it offers several functions, and they are categorized into four major groups: date functions, mathematical functions, string functions, and advanced functions. So for example, if you want to pass current date as a input for a particular column, in those cases you'll be make use of the current date function. Next unique feature is data masking and scrambling. So data masking is the process of obfuscating sensitive data for security purposes. The data masking transforms or masks the data based on the masking technique that you have selected. For example, if the email ID column is to be masked, then you can choose email as the masking technique. Then what happens is, in the email format and the masking format, you select username. In those cases, what happens is it masks the username in the email ID. So the actual email ID will not be moved to the target system. Only the masked email ID will be passed to the target system. So this picture explains how the lookup transformation works. For example, the scenario that it explains is it moves item master data from a source system to the target system, whereas it gets organization code as input, whereas the target system expects the corresponding ID, basically the organization ID. In those cases, what we are doing is we are collecting the organization code from the input data and pass it to the transformation, lookup transformation, which is looking at against the organization data that exists in the target table and maps it and gets the corresponding organization ID. And this one shows the expression transformation in detail, where we create the current date as a creation date and assigning it to a column, and then move on to the target system. This is an example of how the data masking works. So on the right, you can see all the email IDs got masked. So whatever email ID that you receive as input data, you can mask it using these techniques. And in data masking and scrambling, there are many more options like credit card masking. There are so many options available. And this lists all active transformations. Basically what it does is it may change the number of rows passed as input. First, let's take the joiner. It appends records of two or more entities horizontally, which is equivalent to the join or left join, right join that you use in your regular SQL. So the input that you need to pass is two or more entities as input, but it combines it together and returns one single entity as output. Next, we have the normalized transformation. It splits columns of an entity and creates multiple entities. Basically, it normalizes the data. And then the router transformation helps you to split the records based on the filter conditions, whatever you have defined. So it is used to route the data based on the filter conditions to different target systems or different regions, whatever requirements based. Then the sorter, so it sorts the records based on the columns whatever we have defined, either in ascending or descending order. And then the aggregator transformation helps to group multiple records together and then generate aggregated values like count, sum, average. And comparator, so the comparator is a unique transformation that our platform offers. So it is primarily used for setup data migration. What it does is it compares the data of two entities and provides an option to view the difference and to select the records whichever you want to send as output. So in case of setup data migration, we need to compare the existing setups between two systems, or within a same system between two organizations or business units. In those cases, you can make use of this comparative transformation to compare the setup data between the two entities, and it provides the results in three ways, like not in source, not in target, and existing both. And within the existing both, is there any mismatches or matches? So by which you'll be able to identify your, you can do all the setup comparison. Unified transformation combines records of two or more entities vertically. Basically, it's equivalent to the union or union oil in SQL terms. Next, we have the EDA parse transformation, which receives EDA file as an input and parses and returns the data as a JSON format. Later on, we can make use of the JSON to the next transformation, like JSON parser to parse the JSON data and convert it to a structured format, and then we can pass it to any system, whatever you want. The splitter transformation helps you to split the columns having delimited values into individual rows. For example, if your column has 5 delimited values, then it will be converted into 5 different rows. The JSON generator helps you to convert the structured data into a semi-structured JSON format. So in this slide, you can see how a joiner transformation will look like. So this is the data flow execution. Data flow is nothing but which moves data from one system to another system. On the left, whatever you are seeing is the extraction objects, and on the right, one is the data loading object. So the data extraction object extracting data from the source system, and the data loading object loads data into the target system. In between, you can see the joiner transformation, which returns data into the mapper, and then it goes on to the loader. So the example is the source system returns employee data and contact data as two different entities, whereas the target system expects it as a one single entity. So we passed it to a joiner transformation and make it together, and returns as a one single entity. So this slide shows you the features of a validation engine. So there are different types of validations available in the system. Let's see one by one. So first one we can see is lookup based pre-validations. So before we get into the pre-validations feature, the power of pre-validation is if you don't do any validation in your data. See, generally when you move data from one system to another system, the data requirements may not be exactly the same. The target system expects some values in a column in a different way, whereas the source system store it in a different way. So in those cases, mostly the target system fail the data if you pass a wrong input. Okay. So for example, you are passing a input record, one record, which has 10 different errors. What happens is if you don't validate it, and without validation, if you send those records into the target system, it fails it and returns back the first error. Then you need to correct the first error, then you send it back again to the target system. Then at that time you will get the second error. Then you correct the second error, then send it back again to the target system, then you will get the third error. Like that it goes on. So until 10 errors, to correct the 10 errors, you need to do the back and forth execution 10 times. With the help of pre-validations, you'll be able to identify all your data flaws in your input data and correct it in one shot before it reaches into the target system. So literally it saves a lot of time in every single integration and migration projects. So the lookup based pre-validations are nothing but it's validating the input data against the lookup source. The lookup source could be a table or query or a flat file or REST API or SOAP API payload. So against which you can compare your input data. For example, when I load item master data, I want to make sure my unit of measure code, that whatever I receive from the source system is valid or not. So in these cases, what I do is I'll map the unit of measure code against the lookup, which is going to extract unit of measure code from the target system and do all the lookups, validate it, and then it marks whether it's success or error. So you can do two options, like if the input data exists in your system, you can make it success, or the other way, if you want, if the data exists in your lookup source, you can also make it as error. For example, if you want to validate and for duplication kind of a validations. For example, when I insert item as data into the target system, if the item already exists, I need to validate the data. So for in those cases, error type of pre-validations will be helpful. And you can convert this pre-validation as an API. So it is known as VAPI, which is validation API. It makes the validation rule as reusable in multiple loaders. So you can so when you make it as an API, what happens is you write the logic once and reuse it in multiple places. If your logic changes, then you just need to change it in that API alone. Then it automatically gets reflected in all the data loadings. The next set of validations are constraints and the cardinality based validations. The constraints like primary key, unique key, mandatory. So for all those things, you just need to set whether the column is a primary key or unique key or mandatory. Once you define it, if the input data doesn't meet the given constraint requirements, again the validation engine marks those records as error and it will not process the data into the target system. And next comes the cardinality based validations. So cardinality based validations are primarily used in application based integrations and data migrations. So in application based systems, one object may have multiple data sets. For example, if you take sales order data, in the sales order data, you'll have sales order header, sales order lines, and schedules and taxes and so on. In those cases, you need to define whether every header should have at least one line or not. Say, for example, if you want to validate whatever scheduled sales order header that I receive, it must have at least one row, one lines. In those cases, you can define the cardinality as one or many. Once you define, if any sales order header that you receive from your source system doesn't have a line, in those cases, that header also marked as error and it will not be processed to the target system. So this is how the pre-validation results screen will look like in every single load. On the left, you can see all the stages of data loading. And if you click on the pre-validation on the right, you will see all the pre-validation results. Whatever pre-validations that you have defined in that loader, for every single pre-validation, you will get the results like this. How many records it processed and how many got succeeded and how many got failed. And if you want to see the error details, just click on the error count. You will get all the details in the grid itself along with the error message. So in this slide shows the data loading features. In the data loading, so we have covered data extraction. So that's the starting point where we first pull the data from the source, and then we do the transformations, all the active and passive transformations, and then we did the validations, and then comes the data load, actual data loading. So in the data loading, that's a unique feature called batch processing. Batch processing is really required. For example, in application-based endpoints, they provide APIs, but they define some governor limits for every single API. For example, if you move data, if you pass 5,000 records, there's an API which accepts maximum of 5,000 records per call. But you have millions of records to process. But the API can accept only maximum of 5,000 records at a time. In those cases, you need to split all your millions of records into 5,000 of batches. So how do you do that? There comes the batch processing engine. So you just need to define whether you want to split the records into multiple batches and how many batches you want to split, or you can define what's the maximum records per batch. So in our case, if you can define 5,000 maximum records per batch, that's it. The system will take care of the rest. Like it receives millions of records, but it splits the records into multiple batches and then pass into the target system. So you don't need to sit and split all the records into batches manually as per the target system's requirement. So you can define it as per the target system's requirement. If the target system accepts 10,000 records, you can configure it as a 10,000 record. And even within the batches, there are options like if you want to run multiple batches in sequentially or parallelly, that's also available. Again, it depends on the target system's API garner limit. If the target API supports parallel processing, then you can go for the concurrent option. And within the concurrent option, you can define how many concurrent batches can run in parallel and so on. Multi-data support, so it's a feature that helps for application-based endpoints, like as we saw in the previous slide for the cardinality validations. So we can define multiple data sets within a loader. So if you load sales order data, you can define multiple data sets within the same object, like sales order header, line, schedules, and taxes, and so on. In those cases, so it's a combination, the multiple sets put together forms a one single object with respect to ERP systems. Next, we have the preload and postload reconciliation. Basically, the reconciliation is the process of comparing two sets of records to know whether the values of the columns are exactly matching or mismatching. The preload reconciliation compares the source raw data from your source with the transformed data, whereas the postload reconciliation compares the transformed data with the data loaded into the target system. So preload reconciliation, if for example, if the business user wants to know how my data got transformed, in those cases they can make use of preload reconciliation. And then next we have the two features called pre and post processors. So a pre-processor is the step which gets executed before the data loading starts. The example use cases would be like you want to load a data into a table, whereas for every load you want to truncate all the existing records from your target table. In those cases, you can provide that truncate script in this preprocessor. That's it. And then we have the post processor, which gets executed after the data loading completes. So the post processor, again, it could be any SQL query or a procedure. And one more thing that the post processor offers is, with the use of post processor, you can update the status of every record back in your source system if the source system accepts that updates. So this slide shows all the supported endpoints. So again, there are multiple categories, like we support all the major relational databases like Oracle, Postgres, SQL Server, MySQL, and many more. So with the JDBC support, we'll be able to connect to any relational databases and open time series databases like OpenTSDB. And for streaming based integrations, we can connect to Kafka. And on the enterprise systems, we have connectors for SAP and Oracle, EBS Suite. And almost we have connectors for all the major cloud applications like Oracle Cloud, Workday, Salesforce, SAP, C4HANA. And then NoSQL connectors also available. Then big data connectors like Snowflake, Databricks, Redshift, and enterprise storage system connectors like OneDrive, SharePoint, Google Drive. And at the bottom, you can see the API-based connectors like REST API, SOAP API, OData, GraphQL. So by using these generic connectors, you will be able to connect to any systems which may not get listed in this slide. So basically, any modern cloud systems comes under these four categories mostly. So you can connect to any systems and do the integration. So data flow. So data flow is the one which connects the extraction and loading, and where you do all the data mappings. So by using the mapper. So mapper helps you to map the columns between the source and target. It is used to define which column from your target system, from your source system, to be mapped into which column in your target system. So that's the job of a mapper. And then the mapper offers three types of mappings. A map by name. So basically it maps columns which are exactly the same between the source and target systems automatically. And then it offers a pattern matching feature. In the pattern matching, it ignores the characters of a given pattern either in the source or target column, and after that it maps remaining by using the exact matching concept. And next we have the A-pod mapping, which is in a beta version. So it leverages the capabilities of artificial intelligence to fasten the data integration, migration configurations, basically with respect to the data mapping. It utilizes AI techniques to analyze your current data mapping requirements, and it predicts and recommending the data mappings by referring a well-validated library while you create new data mappings. So in this quick video, we'll see how the AI-powered mapping works. So I'm going to create a data flow where I'm going to move item of data from Oracle E-Business to SAP. So these are two different ERP systems where the column names are completely different. Let's see how the AI-powered mapping helps you to do the column mapping quickly. So we are selecting EBS items data object, which extracts item master data from Oracle E-Business Suite. Then we are adding SAP Material Master loader, which is going to load data into the SAP system. We map these two together, and in the mapping, you can see AI-powered mapping. So when we use the AI-powered mapping, it maps all the columns, even if the names are different. So this is how the AI-powered mapping is helping the users to fasten the application-based data mappings. So data integration features. In the data integration space, we support multiple types of integrations like batch mode. So batch mode is nothing but you collect data from your source system in multiple batches and process it to the target system at regular intervals. In some cases, like organization may want to do this every 1 hour or 2 hours, like that. Or also in some cases, if they don't want to disturb the source and target system during work hours, they'll do it after working hours. Or in rare scenarios, they'll do it on the weekends. So for doing the batch mode integration, we have our own engine called scheduler, which helps you to schedule your jobs and take care of the batch mode integration. Next comes the near real-time integration, where, for example, you build a near real-time integration between two applications. The requirement is to, as soon as new data gets created or modified in the source system, that gets interfaced into the target system. So for that, near real-time integration works perfectly. And then streaming like we can listen to streaming like Kafka, and as soon as the data is available, we'll be able to take it and pass it on to the target systems, whatever you like. So API gateway, the API gateway offers all the requirements for the near real-time integration. So basically what it does is it publishes all the integration objects like extraction, data loading, data flow, and process flow, everything as a REST or SOAP API with just a few clicks. So you don't need to write any code. We just we can do it just in a few clicks. We'll be able to publish those objects as a REST or SOAP APIs. You can consume these APIs in any third-party systems for consuming it and make it your real-time integration. When you publish the APIs, you have two choices, whether you want to publish it as in a synchronous mode or asynchronous mode. So that's also possible. Then we offer a process flow to orchestrate complex integrations. So process flow is basically a workflow engine where you can define multiple activities to run one after another, or in a sequentially or parallel, and you can add if else conditions to check conditional logics based on the conditional logic, whether the first job is to run or second job is to run. So everything you'll be able to control, and you can define for while loops to iterated over data sets, and for each iterated records you can call another job like data flow. And then you can define confirmations, approvals. In approvals you can have multi-level approvals, and you can add notifications to send emails once a job is complete within a migration, within a process flow. And using a sleep activity, you'll be able to sleep the process flow execution for a defined time frame temporarily. So these are the data integration features that the platform offers. So this is a sample screen of a process flow screen. So where you can see this is how the workflow configurations will look like. So as we earlier see, the platform offers features for both data integration migration. So the process flow that we saw in the previous slide is for data integration, and migration flow is a unique component that we offer for data migration. So the migration, there are multiple types, like application data migration is the process to migrate data from one application to another application, or within the same application from one version to lower version to higher version, like that it goes. And then setup data migration. The setup data migration is the process to migrate data from source system to one system to another system, or within the same system from one entity, one business unit to another business unit. Also, it helps you to reconcile the setups between the two systems. And then the database migration, by which you'll be able to migrate to the entire database, all the tables and including its structures and data to a different database by using the database migration engine. Next, the migration flow object, which helps you to orchestrate complex data migrations. Within a migration flow, you can define multiple groups. Groups is basically nothing but you can define each module as a group within a migration flow, and within each group you can have multiple objects to run in serial and parallel as you want. Basically, it depends on the functional dependency of the objects. Certain objects can run in should run in sequentially, and certain objects should run in parallel. That's how you can go. So migration flow, by using the migration flow, when you do migrate data migration, there can be hundreds of objects. So in those cases, it's really hard to manage object by object. So the migration flow help you to manage hundreds of objects within a single page. That's the power of migration flow. And you have the entry criteria options to indicate only when a success percentage meets the parent, when a parent data flow meets the success percentage, then only to initiate a child data flow. And similarly, we have exit criteria to indicate whether the success percentage of a data flow to exit, and we have status indicators and dependency within a group and across groups, and approvals in between data flows. So this is how the migration flow definition will look like. So the example we have taken is we can see multiple groups. Basically, every module can be defined as group, and within a group, you can see a few objects are running in parallel, and then sequentially, for example, in an inventory module, you can run organization and unit of measure in parallel. After that, you can start the item master and then the item divisions. So it all depends on the functional dependency of those objects. You can define your migration flow completely. And once you execute this is how the execution result will look like. And on the top, you can see all the status indicators, green, amber, red, and gray. So, which helps you to identify where the data migration status is. Like how many objects are in green and how many objects are in amber and red. So basically, in this case, we have defined if any object success rate is more than 50%, and that put it under green bucket. But these numbers are completely configurable as per your business needs. And if there is any error in any of the objects, you'll get to know it in the right itself. And by clicking the count, you'll be able to see all the error records along with the error message. So when you have hundreds of objects to migrate, by looking at this one screen, you will be able to know the entire data migration status quickly. Thank you, and please feel free to reach me for any detailed demonstration and proof of concept. We'll be happy to assist you and make your data integration and migration journey a smooth one. Now it's time for Q&A.
Sure. So thank you, Ratnikaran, for this wonderful session. Yeah, we move to the Q&A thing. And I have some couple of questions coming for you. So the first one is, what performance monitoring tools are available to track and manage concurrent workloads in real time? Can you quantify the platform's ability to detect and address performance issues promptly?
Yes, so we have monitoring dashboards by which you'll be able to monitor all the jobs that are running, and we have the concept called estimated time. So you can define time for each and every object. So whenever a job exceeds the defined time limit, you will get an automated notification. So it is the users like you don't need to sit in front of the system whether my jobs are running in on time or it is taking unusual time. You don't need to sit in front of the system. You can be rest assured, and once you define all the required configurations.
Got it. Thank you. The second question I have for you over here is, can you explain how your platform efficiently handles diverse data types, including structured, unstructured, and semi-structured data, ensuring seamless integration with existing system for data analysis?
Okay, so it covers everything like structured data, unstructured data, and semi-structured data. To explain it in detail, if you take structured data, for example, structured data is very common, so every single platform supports. And semi-structured like JSON and XML are supported. For example, if you will consume any REST or SOAP API, you will get the response in semi-structured format only. So that's been handled very well. Okay, and unstructured cases, for all the enterprise storage systems, we deal with all the unstructured data. It could be any kind of a file. We'll be able to seamlessly move or interface those files as well from any system to any system.
Got it. Thank you. And I have the third question coming up for you is, what performance monitoring tools are available to track and manage? Oh, sorry, I have asked this. Sorry, my bad. Can you explain how your platform efficiently handles diverse data types? I think Sorry. Could you explain how your platform ensures data accuracy and consistency even when dealing with multiple data sources?
So that's where the power of pre-validation comes in. So it validates before your data reaches the target system. Okay. So by which you'll be able to, it really reduces the time considerably. So without pre-validation, it's really a tedious job to process the data between two different systems. When the target system's requirement is completely in a different way, where your source system passes the system in a different way. In those cases, first you need to validate, first you need to transform based on your target system's requirement, and then validate whether it meets all your data target systems requirements. So that's how the accuracy is measured, and the system provides a very detailed report. Like you don't need to get into the logs and see which data getting filed, not like that, unlike that. So everything is comes in a grid form. You'll be able to easily see the data and along with these errors. And not only in the grid, if you want to share it to your business users, you can download it in Excel format and share it with your business and get it corrected, and then reprocess the corrected data. So that's how we'll be able to manage the accuracy.
Okay, that's helpful. I have one question. Could you explain how your platform facilitates the creation of data pipelines to automate the flow of data, streamlining the process for efficiency and timely insights?
So data flow is the one which is equivalent to the data pipeline term. So so first we create a data extraction which extracts data from the sources. So we have kept it different. Data pipeline is a one object, but again it includes two different objects. Like extraction is a different object and data loading is a different object. When it combines together, which forms a data pipeline. Why we have kept these as two different objects, like data extraction as a separate one and loading is a separate one, as you can make use of the extraction object not only as a source for your data pipeline, but also as a validation lookup repository or as a transformation lookup repository in some other processes as well. And similarly, you can make use of the data loading not only for your data pipeline. If your users want to pass data as a wanted to do kind of a mass data loading, they can prepare the data in an Excel file manually and pass it onto the loader. So that's how it achieves. Okay, so data pipeline is in our terms it is exactly equivalent to the data flow that we saw. So in the data flow we have the extraction, and then in between we have a mapper, and it goes onto the loader.
Got it. So Ratnikaran, we have one question from our audience. He's asking, does a product compare with market competitors in terms of feature, pricing, etc.?
Yes, we do have. If we can reach out offline, we'll be able to share it.
Okay, got it. Also, he's saying that they have an experience more than 10K migrations from their past. Apart from their experience, the key reason for organization to choose Changes data there, why they choose us, and how is the implementation done for this product? How manual is the process?
Okay, very good question. The first one is they don't need to start the data migration from scratch. That's number one. Okay, the reason is if you go with when you come to us Changes, we provide a pre-built adapters. So from day one, you'll be able to start your data migration. Okay, and in addition to, so that's one option. And another key feature that we offer is it's a one single platform which you can use it to clean your data and profile your data, transform your data, enrich your data. So everything comes in a one single platform. So that makes the value proposition as a better choice for our customers.
Got it. Thank you for that. One more question. For the AI mapping feature in the data flow mapper, does the AI engine need to access the source and target database to read the models, or it's solely based on learning from your previous mapping?
So it currently solely based on the previous mappings. So based on that, we have built the validated library. So from based on that only currently we provide, but we are keep on improving that to make it to the next level, like all the predictions and everything is coming soon.
Got it. And is the AI Power Mapper ready to be used?
Yeah, it's in a beta stage, and maybe in the next 1 or 2 releases, it will be available for all the customers to make use of it.
Great. So we are running out of time, but this is the last question that I want to take. How the platform deals with duplication populated on runtime?
Duplication populated on the runtime.
On runtime.
Duplication population on the runtime. Maybe not sure the user what is the meaning.
Yeah.
From my perspective, like when we load data into the target system, if your source system contains duplicate data, there's a chance for duplication in your target. Okay. So again, it can be stopped by using the pre-validation feature. So when we have the pre-validation in place, so it's going to validate the data, whether the same data already exists in your target system before it moves into the target system. So that's how we'll be able to take care of the duplication. And there are 2 cases, like within the input source, maybe even within a single execution, your input data may have duplicates. So we have the constraint based validations, like unique key kind of unique constraints. You'll be able to add it in the data loading configuration itself. Once you have defined it for the column, once you define a column as a unique constraint, if any duplicate duplicate value is passed as input to that column, so the system automatically mark the record as error, and it will not move the duplicated records into the target system. So that's how there are 2 ways. So we'll stop before in the data, we validate within the data itself, and another thing, we validate it against the whether the data already exists in the target system. So that's how these 2 ways will be helpful for avoiding the duplication.
Got it. Thank you, Ratnikaran, for answering all those questions.